One last topic in this unit, and the last topic that we have in this unit is Lewis dot diagrams. Lewis dot diagrams are just a way of writing out how many electrons are in the valence shell, so the outermost energy level, based off of the modern atomic theory, which is just your orbital diagrams, electron configurations, or noble gas configurations, depending on what you're looking at. So with your Lewis dot diagram, how you draw them is you actually put your element symbol here in the middle. So this has an X. There is no element just an X, so this is just a fictitious symbol. So you would have like Li for lithium or Mg for magnesium or whatever you're dealing with would go in the middle. And then you place dots around the outside just to show how many valence electrons it has. What that actually shows us is the bonding places as we get into what's called the Vesper theory down the road. So there's an easy way to find the number of valence electrons. We know that these noble gases complete out a full valence shell. And as they complete out that full valence shell, when you go to the beginning of the next row, you're starting your valence shell. So that means that your valence electrons only come from the S block on the periodic table and the D block on the periodic table. Not D, P, sorry, I was reading this D up here. The P block up here. The D electrons here and the F electrons down here actually jump inside of the atom. So if you go across this row, I know it's covered up, but this is 4S. And then right here is 3D. So that's an inside energy level, so it's not on the outside shell. So these would be on the outside shell, 4S, and then 4P down here would also be in the fourth energy level. So these would both be on the valence shell. So because of that, as we count across, you end up with the magic number of 8 valence electrons. 8 valence electrons and 8 electrons in general is going to be our magic number for most of the things moving forward as we go into the atom and bonding. So as we look at our valence electrons with a magic number of 8, you're going to put 2 per side. 2 on the top, 2 on the bottom, 2 on the left, 2 on the right. And they go around kind of like a box around that element. You can only put 2 electrons per side because they're going to bond in pairs, so that's going to be able to show that. The only real rule that we have with these, it's kind of like the hunds rule. And with hunds rule is the electrons are going to spread out first around the atom. It doesn't matter which side you start on. I know some teachers always teach like you're going to start at the top and then you're going to go clockwise and then counterclockwise to fill. It doesn't matter. What you're going to do is you're just going to start on one side of the atom and you're going to put 1 dot per side first, like top, left, right, bottom, however you want to do that. And then if you have electrons that you still need to fill, you're going to double them up if you have to. So you're going to start on one side, 1 dot per side first, and then double them up if you necessarily have to. So we have 3 elements here that we're going to write these for, and I have a periodic table down here. I'm just going to write down what we're dealing with. We have tin, we have oxygen, and we have magnesium that we're going to write out our Lewis dot diagrams for. Maybe. Where's my document camera? Sorry, I lost it. So here's my document camera. I've got my periodic table. So when we're going to find the number of valence electrons, you could do a full electron configuration if you really wanted to. That's a whole lot of work. I don't do that. What I do with these is everything in this first group right here all have 1 valence electron. So this is like 1s, 1, 2s, 1, 3s, 1. So these all have 1 valence electron. These all have 2 valence electrons. 1s, 2, helium's down here. Remember, it kind of goes right here. And then 3s2, 4s2, all the way down. So as we're looking at these, everything in the second group all have 2 valence electrons. Group number 13 all have 3 valence electrons. These fall inside of the atom. So they're not in the valence shell, so these all have 3 valence electrons. Those all have 4. These all have 5, 6, 7. And then helium, remember that guy has 2. Everything else down below helium all has 8 valence electrons. So helium only has 2 electrons, so that's why it only has 2. Remember, it kind of can be written over here above beryllium. And then neon through ognesium, that would all be 8 valence electrons. So this is kind of a quick reference in order to do these. So the first example that we have is tin. Tin has 4 valence electrons. If I drew out the noble gas configuration, which you don't have to do this, I'm just showing you where they're coming from. Tin, I'm going to pick krypton, and then I'm going to start back up with 5s2, 4d10, and then I have 5p2. So when you write all of this out, this is in the 5th energy level, the 4th energy level, so those aren't on the valence shell, 5th energy level. So I have 2 electrons here, 2 electrons there, that gives me 4. So that's just showing you where that 4 came from. It's just a quick reference, the way that I wrote it here. So I'm going to place these 4 electrons in a Lewis dot diagram by starting with the element symbol in the middle. I'm going to place 1 electron per side first. I had 4, I used 4 electrons, I'm done. How I could not write this, like I couldn't put 2 and 2 like that. You have to spread them out before you double them up, so that wouldn't be correct. Oxygen. Oxygen is here. It has 6 valence electrons. So I'm going to place 1 per side first. There's 5, there's 6. So 2 sides have 2 dots, 2 sides have 1 dot. It doesn't matter which side has the 2. I could have put the 2 here and here, I could put the 2 here and here. It's up to you. It doesn't matter. Magnesium, I start with the element symbol. Magnesium on the periodic table is, ooh, I'm sorry, can't see that. It's right here. So with magnesium being right here, it has 2 valence electrons. So I'm just going to put 1, 2. Again, I could have written it like this. I could have written it like this. It doesn't matter which 2 sides get the 2 electrons, as long as only 2 sides have those 2 electrons. So that's actually the conclusion of this unit. We started with the history of the atom. We moved through how to find protons, neutrons, electrons. We looked at isotopes, average atomic mass. Sorry, that's my hands. Average atomic mass. What else did we look at? We also looked at orbital diagrams, electron configurations, and then our Lewis dot diagrams. So this very last slide of your notes has all of the different topics that are on the test. We will review before the test, and then we'll actually take the test the day after. So this is everything that you need to know that is on the test.